Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we from Bmkt 1 section 11 will present about the force and factor of safety analysis from the actual structure. So firstly, for introduction, roof truss are an important component for a building structure, providing support for the roof and distributing the load to the walls and foundation. They are designed to handle various forces and ensure the stability and integrity of the roof system. Understanding the force acting on the roof truss and ensure an adequate safety factor is important to prevent structural failure, especially in areas exposed to heavy snow, wind, or seismic activity.
Okay, for statement of main idea, for this project we focus on monopitch roof truss. Monopitch roof truss are gaining popularity in modern architecture. Their simple design and efficient use of material, and they use single pitch roof is commonly used in resident, commercial, and industrial building. First acting on monopitch roof truss and ensuring an adequate factor of safety is important to prevent structural failure and ensure long-term durability.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Elias. So the objectives for this assignment is to draw detailed free body diagrams of the selected monopitch roof truss, to develop equilibrium equation based on the FBD, to analyze the forces in various members of the roof truss, and to calculate the factor of safety for the roof truss.
Okay, first step for calculation, we need to change the distribute load to concentrate load and determine the magnitude of concentrate load. For the force equal to area under consideration, we get 1 per 2. For the force equal to area under consideration, we get 198 Newton. Okay. Second step, we determine the centroid or center of gravity of the body. For triangle centroid, we get 3 meter. Second step, we draw free body diagram, and last step, we apply equation of equilibrium to determine the internal loading. For Fy, we get 198 Newton. For moment, we get 594 Newton meter.
Hello and Assalamualaikum. Firstly, I would like to express my gratitude for being given the opportunity and being able to present about shear moment diagram calculation. So, the important part for this calculation is we have 8 steps to complete this calculation, which I already written in point form. So, the first part is we must do calculation for distributed to concentrated calculation. The second one is equilibrium equation. The third one is analysis shear diagram. The fourth one is the calculation for cutting X location calculation. And the fifth one is area under graph. The sixth one is equilibrium equation. And the seventh one is the continuous calculation from the previous. And the eighth one is which we get the value for moment diagram and shear diagram. So I will explain a little bit step by step. Okay, so for the distributed and concentrated part, first we have a problem, which is the given problem have distributed force. So we need to convert it to concentrated, and we get 198 kilonewton. We use formula in area under a graph to convert distributed force to concentrated force. The second one is equilibrium equation. So how we finish this? After we have the concentrated force value, we find the moment at A, and then we get moment B is 132 kilonewton and moment A 66 kilonewton. How we get moment A? We simply just subtract 198 subtract by 132, then we get 66 kilonewton. Then we proceed to shear diagram. So for the shear diagram, we just need to make diagram based on the concentrated drawing that we have already made. So the first point is it is increasing 66 kilonewton, then it decreased 198 kilonewton, and it increased back to 132 kilonewton. So for the moment diagram, we just follow back from the shear diagram and find the maximum value, which is M, and we get M from the shear diagram. Okay, so from the shear diagram we cut X and we do again area under graph and convert back distributed to concentrated, and we get the value, which is 44/18 x square. And then we proceed to equilibrium equation. We get negative 66 kilonewton plus 44/18 x square plus V. V is the shear diagram. And how to find the X? How we find the X is we just put V equals to 0 and we get X 5.2 meter. So we proceed for the moment diagram. How we want to find M? Using the X equals to 5.2 meter, we use back the equation V equals to 66 minus 44/18 x square, and then we integrated it so that it get a moment equation. So using the moment equation, we just put 5.2 meter, and then we get the value for moment 228.630 kilonewton. So that's how to calculate shear moment. We can get the value, and also that's the way to produce shear and moment diagram. Thank you.
The force and factor of safety analysis of the multi-story commercial building indicate that the structure is safe and meets the necessary safety requirement. The calculate factor of safety for the steel beam 1.5 and concrete floor 2.0 are above the required minimums, ensuring that the building can withstand the applied load without failure. Regular inspection and maintenance along with structural health monitoring are recommended to maintain long-term safety and performance. Overall, the structure is deemed secure for its intended use, with sufficient capacity to handle expected load and environment impacts.